All right, class, on this last part of section 2.3, we're going to take a look at a couple laws I'm going to throw at you. Here we have, if we want the complement of the union of A and B, you can do the intersection of A and B complements, each respectively. And so, in other words, this is something that you could do instead. It's very different from that very last example I had. This is the intersection rather than the union. It happens to work. And then if I want the intersection of A and B in its complement, you could do the complement of A and the complement of B and actually find their union. So it's a little bit of an interesting thing, where you can just follow the methods that it's already given for you. And then also we have this rule here, and this is the cardinal number of the union of A and B would be equal to the cardinal number of A plus the cardinal number of B, subtracting the intersection of A and B's cardinal number. So this is, so we don't count these elements twice. And here, let me show you a quick example of this last one. So let's say A was 1, 2, 3, 4. And let's say B was 3, 4, 5. So the cardinal number, if I want to find the cardinal number of their union, first of all, the union would be 1, 2, 3, 4, 5. So the cardinal number is 5. There is a total of 5 elements in that set. So what this is saying is you would take the cardinal number of A, which is 4, add it with the cardinal number of B, which is 3, and then subtract the overlap, the intersection here. The intersection is 3 and 4. So there's an intersection of 2, so the way that goes is you do 4 plus 3 minus 2, and that also gives you 5. So that's what it's saying to do there. Now, this last example, it says, let A, B, and C be sets in the universal set of U. Does the intersection distribute over the union? In other words, can I have the intersection distribute like that? In other words, can I have the intersection of A and B and then do the union of A and C? And so what we want to do is check this out. So what this is saying is, if I follow the order of this, does it match if I followed the order of the right side? So let's take a look at the left and see what regions I would result with. So I've got B union C. So if I'm looking at B and C, I've got all these highlighted regions. I've got region 3, 4, 5, 6, 7, and 8 all highlighted. And then if I do the intersection of A with that, the only ones that work are region 3, 6, and 5. So that would be the result of the left side. So we got, I'll write that, we got regions 3, 6, and 5. And that was supposed to be an R, but region 3, 6, and 5. Okay, and then if we do the same thing over here, let's take a look. It says do the intersection of A and B first. That would give me these two. And then the intersection of A and C, which would give me these two. And then it's saying do the union of those, which means I would combine all the ones that I've got highlighted. Notice I just shaded in the same things. So that is the union between those two intersections. And it does give me the same result. This is region 3, region 6, and region 5. So the answer is yes, it does.